here, y equals f of x on the top, y equals g of x on the bottom, a to b. Let me make it a little more rounded there on the top one there. What if I rotated that about the x-axis? Gonna have a hole in the middle, yeah. I would have a hole in the middle. I'd have basically a bottle shape. And then this part, yeah, would come out, well, this part would not be, you wouldn't be able to see it because it would be inside of it. So here's, try to get this in your mind's eye there. Yeah. If I just rotated this, it's going to have a hole, shape with a hole in it. And the picture in the book, of course, would be much better than I could jot up here. Well, the thing of it is here, if I split this up into the intervals, notice what I get instead of this. What do I get? Donuts? The washers, yes. I get the washers instead. Because these, if I just rotate then those rectangles about, I'm getting the washers. The discs with holes in them. Okay? Yeah, this is where the washer method comes in. Well, what it boils down to is basically this. If I take the integral of the outer one, so the volume of this solid here is going to be, if I take the volume of the outer one, without regard to the hole there, that's just this method. And then what I can do is take the other one and subtract it off, right? Wouldn't that work? Just take the volume I would get if I just did that f of x rotated solid, make it a solid from the function down to the x-axis. Do that solid, and then just take off the volume that would be the hole inside, which is, wouldn't that be the volume of the hole right there? G of x is the solid generated by g of x. Just subtract the two. So if I combine those, just combine them into one integral, here's the washer method. The volume is the integral from a to b of pi times f of x squared minus g of x squared dx, where f of x is the outer, g of x is the inner. A lot like the area between, except, we've got squaring and pi and all that, but a lot like it. That's the washer method. And it's so called because you're just going to have a hole in the solid in your figure. Yes. Okay. So let's do one of those. Find the volume of the region bounded by y equals x and y equals x squared rotated about the x-axis. Okay, so we got y equals x squared so rotating this little piece right here about the x-axis. And again, it's important to note there, I do want to do rectangles like this, don't I? That'd be a whole lot easier to deal with than the other way, rectangles. So this is, again, integrating with respect to x, but also noting that is perpendicular to the axis of rotation. So I'm integrating this way, and it's perpendicular to the axis of rotation. So that's the washer method, which is just an altered form of the disk method, because this thing is just going to have a hole in it. Or part of it cut out. Actually, I don't think this would actually have a hole in it, would it? Be kind of a hat shape. So the volume here is, now, all right, so we do the top, basically, the outer, which is the top one, minus the bottom one, but it's squared. So it's pi times the outer one squared, which the outer one's which one? The y equals x, so I would take that one and square it. Then the inner one is the x squared one, so I'd take it squared, subtracted, dx it. Now what about the limits of integration? Yeah, it's where they equal each other. Looks like 0 and 1, but we better be sure, right? So set the two equal, just like we did previously there. Yeah, and it works out. Subtract the x, factor off an x. Yeah, so that's 0 and 1. 0 to 1. That's where they cross. There's our integral. Pi times x squared minus x squared squared dx which works out being what, 1/3 x cubed minus 1/5 x to the 5th, 0 to 1 times pi. Have my pi there. So that'll be pi times, it'll be 1/3 minus 1/5 minus 0. 15, so it's 2/15 times pi. Not much of a volume, but that's what it is. Excuse me. Questions or concerns? Do one more of those, and should be about all the time we have today. All right. So do it like the region bounded by y equals x squared plus 1 and y equals minus x plus 3 is rotated about the x-axis. Find the volume. Okay, well, here's the picture. Y equals x squared plus 1. Looks like that. Y equals minus x plus 3. 1, 2, 3. Down 1 over 1. Looks like that. Rotating that region bounded there by those two about the x-axis. I want to find the volume of it. Well, obviously here, I'd want to integrate this way, right? With respect to x. I wouldn't want to go sideways, would I? Because there are some where we will integrate with respect to y, but I don't think that's what we want to do here, is it? I wouldn't want to turn that around. Okay, so it is integrating with respect to x, which is perpendicular to the axis of rotation. This method, in this case, Washer method. Washer method says to find your volume is you take the pi times the outer one. Which one's outer? Be the line again, right? Take that squared minus the inner one squared, which is the x squared plus 1 squared. Don't forget to square them. Then you subtract them. So again, something like that, probably square both those out, see what happens. So that'd be, oh, what about these? No, forgot my limits. Well, you find the limits, set them equal. X squared plus 1 equals negative x plus 3. Make one side 0, so I'd add the x, subtract the 3, so it'd be x squared plus x minus 2 equals 0. Right? Which factors as x plus 2x minus 1? So it's negative 2 and positive 1. That's what I get. Does that sound right? Is that okay to you? Okay. So we integrate that. Negative 2 to 1. Square both those out. Negative x times negative x, positive x squared. Negative x times 3 is minus 3x, but then you have another minus 3x, that's minus 6x. Positive 3 and positive 3 is positive 9. Then we'll have minus, square that out. So that'll be x squared and x squared will be x to the 4th. X squared is 2x squared plus 1. Times pi. Forgot my pi. That'll be pi, negative 2 to 1. Got a minus x to the 4th. Then we'll have x squared. That'll be a minus 2x squared, so that'll be minus x squared. Minus 6x, doesn't have anything there to go with. 9 minus 1, so that'd be plus 8. I believe is how it would all happen. Antiderivative, so that'll be pi times negative 1/5 x to the 5th minus 1/3 x cubed. That'd be 6 over 2, so it'll be 3x squared plus 8x from negative 2 to 1. Plug in 1, that's easy, so it'd be 1/5 minus 1/3 minus 3 plus 8. Plug in the minus 2, so it'd be minus 1/5. Minus 2 to the 5th minus 32. Minus 1/3. Negative 2 to the 3rd is negative 8. 3 times negative 2 squared is 3 times 4. And 8 times negative 2 is minus 16. So this and this would be 32/5. This and this would be positive 8/3. Minus 12, minus 16. But I'm going to minus all those, so what do I get? Negative 1/5 minus a third minus 3 plus 8 be minus 32/5 minus 8/3 plus 12 plus 16. 23.4 pi, or, that's fine.